Mabuhay everyone, this is Hernan Pantolla and together with Dr. Rechel Arcilla, we conducted a study entitled Monitoring the Response of Bulacan Rice Yield to Environmental Indicators Using a Bayesian Framework. For the motivation of the study, the most important crop for the Filipinos is rice, which is domestically known as palay. It is a good gauge for the nutritional and economic status for the Filipinos, specifically among the poor. Rice has a high susceptibility to the environmental changes being cultivated in the fields. Therefore, extreme weather events, including typhoons, droughts, and others, could be detrimental to it. The integration of climate change in modeling crops for a smaller area and creating policies based from the results are being called for by international and local organizations, including the United Nations for the Sustainable Development Goals and the Climate Change Commission for the National Climate Change Action Plan. The study focused on Bulacan due to its proximity to the Metro Manila and the availability of data. For the objectives, it aims to identify the effects of selected environmental variables, both local and global, to the rice yield of Bulacan, which serves as the dependent variable. It also aims to discriminate the importance of the variables through weighting procedure using the posterior inclusion probability and corresponding magnitude via the average coefficients. The selected Bayesian framework was used to answer these objectives. For the methodology, these are the datasets that were used in the study. The yield and spatiotemporal weather variables were taken from local sources, whereas the global climate indicators were downloaded from various websites managed by international organizations. For the data preparation, the necessary procedures were done to make all the variables consistent to a quarterly frequency. The yield was calculated as the ratio of volume of production against the harvested area. There is a total of 104 quarters starting from the first quarter of 1993 to the fourth quarter of 2018. The first 96 data points were used for modeling while the remaining 8 was used for testing the forecasting accuracy. This study applied the Bayesian structural time series modeling procedure which was developed by Scant and Varian in 2019. The forecasting accuracy was evaluated using the mean absolute percentage error or MAPE. We proceed to the results. In the BSTS modeling, the coefficients here are the average coefficients over all the models, including the models where the variables are not contained. The posterior inclusion probability, on the other hand, shows the importance of the variables in explaining the data. Specifically, rainfall should always be included in modeling the yield, having a PIP at around 78%. Notice that rainfall has the highest PIP, while wind speed has the lowest coefficient. Both coefficients also show detrimental effects to the yield. Intuitively, the combination of these two variables shows that typhoons, especially the strong ones, are examples of extreme weather events which are considered by the experts as a byproduct of climate change. Humidity has the highest contributory effects to the yield. Now, every PIP of the greenhouse gases is around 62%, but only N2O or the nitrous oxide is contributory, although the effects are marginal. The maximum temperature and minimum temperature have around 50% PIP but have contrasting effects. Hence, it is important to use these variables separately for the yield to avoid loss of valuable information. Lastly, these three global indices may be discarded already in modeling the yield since all the coefficients and PIPs show that the variables are negligible in modeling the yield. So this is the forecasting plot, and here you can see that the MAPE is shown to be 7.07%. Thus, the model shows a promising forecasting accuracy. Here we can see that the third quarter of 2018 has the highest error. Typhoon Ompong, a signal number 5 typhoon, struck the Philippines and damaged the agricultural sector and infrastructures of the country quite hard. Now for our conclusions and recommendations, particularly in the policy implications, the application of the BSTS model shows much potentials due to its robustness and easy applications. This can be used for other crops, economic studies, and areas among others. The results of this study may be used for policy development or improvement, including rice importations. Lastly, the inclusion of other variables such as farm management practices and other population-related factors may be useful in future studies. So that ends our presentation. You may send an email for questions and thank you for listening.